Fan considerations. When designing a computer system, managing the thermal environment is just as critical as selecting the processor or the power supply. If the internal components get too hot, they will automatically slow themselves down to prevent melting, a process known as thermal throttling, which completely destroys system performance. For a hardware technician, understanding proper fan considerations is the key to building a machine that runs at maximum speed while remaining quiet and stable. Fan sizes and acoustics. The first consideration when selecting a case fan is its physical diameter, which is measured in millimeters. The absolute most common sizes found in modern desktop computers are 120 millimeter and 140 millimeter fans. As a general rule of physics, a larger fan is almost always better than a smaller fan because it can move the exact same volume of air while spinning at a much slower speed. Because it spins slower, a 140 millimeter fan generates significantly less motor whine and air turbulence noise, making the computer much quieter when building or upgrading a system. A technician must always consult the computer case manual to see exactly which fan sizes the front, top, and rear mounting brackets will physically support. Airflow versus static pressure. Not all fan blades are designed to do the same job, and placing the wrong type of fan in the wrong location can severely cripple a computer's cooling potential. High airflow fans. These fans feature thinner, more vertical blades, and are designed to move a massive volume of air very quickly through an open space. They are perfect for use as standard case intake or exhaust fans where there is nothing blocking the air path. Static pressure fans. These fans look distinctly different, featuring wider, highly curved blades that are packed closely together. They are engineered to forcefully push or pull air through thick, restrictive obstacles. A technician should always use static pressure fans when attaching them directly to a dense processor heatsink, a liquid cooling radiator, or a case intake panel that is blocked by hard drive cages or thick dust filters. Determining airflow direction. One of the most common mistakes a beginner makes is installing a fan backward, completely ruining the airflow path of the case. You can easily determine which way the air will flow by looking at the physical frame of the fan. Air is almost always pulled in through the open, unobstructed side of the fan. Blades. The air is then pushed out through the back side of the fan, which is easily identified by the plastic crossguards holding the central motor in place. Many modern fans also have tiny arrows physically molded into the outside plastic edge, with one arrow pointing in the direction of the blade rotation and the other arrow pointing in the exact direction the air will exhaust. Positive and negative pressure layouts. When installing multiple fans, a technician must carefully balance the intake and the exhaust to control the air pressure inside the computer case. If you have more fans blowing air into the case than blowing out, you create positive pressure. This is highly recommended because the extra air is forced to leak out of the tiny cracks and seams in the metal chassis, which prevents dust from sneaking in. If you have more fans blowing air out of the case than pulling it in, you create negative pressure. While this can sometimes cool a graphics card slightly better, it turns the computer into a vacuum cleaner, sucking massive amounts of dust in through every unfiltered gap and optical drive slot, which will eventually choke the system. Power and control, PWM versus DC. Finally, a technician must consider how the motherboard will control the fan speeds. As we briefly touched on earlier, basic fans use a 3-pin direct current or DC connector, meaning the motherboard can only control their speed by raising or lowering the raw voltage. Premium fans use a 4-pin pulse width modulation, or PWM, connector. This extra fourth wire allows the motherboard to send precise digital signals to the fan motor, intelligently ramping the speed up exactly when the processor gets hot and dropping it down to a silent whisper the moment the user closes their heavy applications.